we have here the trigonometry problems. So first problem, we have at a certain horizontal distance from the foot of a vertical cliff, the angle of elevation of the top of a flagpole 50 feet tall standing on the edge of the cliff 40 degrees. From the same position, the angle of elevation of the foot of the pole is 35 degrees. How high is the cliff? So as we discussed before, the angle of elevation, this is the line of sight of a person or an object here. And if you look up, that is what you call the angle of elevation. So we have here the flagpole, which is 50 feet high, and here is the cliff, and this is the height of the cliff, and this is the distance of the um, cliff and the object. Then this is the angle of elevation of 35 degrees and the angle of elevation of 40 degrees. So we will create an equation. So we have here tangent 35 degrees is equals to y over x. So in 35 degrees, this is below the flagpole. We have the opposite, which is y, over the adjacent, which is x. Then the equation number 2 is tangent 40 degrees is equals to y plus 50 feet over x. So we have tangent 40 degrees here. Then the opposite is y plus the height of the flagpole, since the angle of elevation is from the top of the flagpole. So you have to add the y and the 50 feet height of the flagpole over x, which is the adjacent. So we will be using the TOA or the tangent. Tangent 35 is equal to 35 degrees is equals to y over x. So we will solve for the initial value of x. So we have x is equals to y over tangent 35 degrees. So this is our initial value of x. So we have to substitute the x into the equation number 2. So we have tangent 40 degrees is equals to y plus 50 feet over x. Then tangent 40 degrees is equals to y plus 50 over y over tangent 35 degrees. So we will just have to multiply the denominator or cross multiply. So we have y over tangent 35 degrees times tangent 40 degrees is equals to y plus 50. So the numerator will remain. Then we will be using the calculator to solve this, and we will be having 1.20y is equal to y plus 50. Then we have to transpose the y into the left side. So we have 1.20y minus y is equals to 50. Then 1.20y minus 1y, since the y has a 1, is equal to 0.20y is equal to 50. Then we will divide both sides into 0.20. Then we have to cancel. So our y, or the height of the cliff, is 250 feet. So the problem number 2, we have at a certain point of the angle of elevation of the top of a flagpole, which stands on level ground, is 35 degrees, 75 feet. Nearer the pole, the angle of elevation is 50 degrees. So how high is the pole? So this is our pole. It stands on the ground. Then the angle of elevation is 35 degrees. So this is a certain point of the angle and it is 35 degrees. So it is said that 75 feet from the pole to the certain object, there is also an angle of elevation which is 50 degrees. So the question is or how high is this pole? So let y be the height of the flagpole. So this is the height of the flagpole. Then I will be using the tangent, which is opposite over adjacent. So since I already have a given or the adjacent is already a given, so all I have to do is to solve for the tangent 50 degrees is equals to y over 75 feet. Then we have to cross multiply. We have y is equals to tangent 50 degrees times 75 feet. And the height of the pole is 89.38 feet. Next, we have the problem number 3. 2 points A and B is 180 feet apart, lie on the same side of a tower on a hill and in a horizontal line passing directly under the tower. The angles of elevation of the top and bottom of the tower viewed from B are 42 degrees and 34 degrees, respectively, and at A, the angle of elevation of the bottom is 10 degrees. Find the height of the tower. So this is our hill and this is our point A and B, which is 180 feet apart. So this hill, there's a tower. This is the tower. There's a tower at the top of the hill. Then in the point B, there's an angle of elevation from the bottom. This is the bottom of the hill, of the tower rather, which is 34 degrees. And at the top of the tower to the point B, the angle of elevation, which is also 42 degrees. Then from the bottom of the tower to the point A, we have 10 degrees. The angle of elevation of 10 degrees. So the question is, what is the height of the tower? So this is the tower. We will going to find the height of the tower. But we still have a missing um value of a variable. So let x be the distance between point B and the y. So the point B and the y, we will have to solve for the distance first in order to solve for the height of the hill and the tower. So let y be the height of the hill. So this is the second one that we are going to solve. And let h be the height of the tower. So this is the height of the tower. First, let's create our equation, which is tangent 34 degrees. So this is the 34 degrees from the bottom of the tower to the point B. So we have y over x. So this is the opposite over the adjacent, which is x. Then tangent 42 degrees. So our 42 degrees is from the top of the tower to the point B. So we create an angle of 48 degrees. So y plus h. So y plus the h, the height of the tower, over x. This is your opposite and your adjacent is x. Then the tangent 10 degrees from the bottom of the tower to the point A. So we have the opposite, which is y over 180 plus x. So this is your adjacent. Since there's your the distance between the point A to B is given, you will just have to add the x. So let's create our initial value of our y. So we will be using our equation number 1. So we have tangent 34 degrees is equals to y over x. Then let's cross multiply. So we have y is equals to tangent 34 degrees times x. So this will be our equation number 4, and also our initial value of y. So next is we will just have to substitute the y into the equation number 3. So we have, I am going to choose equation number 3 because we just we we need to find the x first. So we will be using the equation number 3. So we have tangent 10 degrees is equals to y over 180 plus x. Then let's substitute. We have tan 10 degrees is equals to tan 34 degrees times x over 180 plus x. So all we need to do is just to cross multiply. So we have 180 plus x times tangent 10 degrees is equals to tangent 34 degrees times x. So we have let's multiply 180 times tangent 10 degrees is equals to 31.74. Then x times tangent 10 degrees is equals to 0.18x. Since they are both positive, so the product is also positive, is equal to 0.67x. Next is you have to transpose the 0.18x to the right side since the other x is there. So we have 31.74 is equal to 0.67x minus 0.18x. Then 31.74, let's subtract, so we will be having 0.48x. Then let's divide both sides into 0.48, and let's cancel, and then divide the 31.74 divided by 0.48. So our x, or the distance between point B and y, is 64.78 feet. So the next step is let's substitute x into equation number 4. So this is our equation number 4 and our x. So we have y is equals to tangent 34 degrees times x. Let's substitute. Y is equals to tangent 34 degrees times 64.78. And our y, or the height of the hill, is 43.69 feet. So we already have the x and the y, or the distance of point B and the hill and the height of the hill. So the last step is to substitute x and y into equation number 2 to get the value of to get the height of the tower. So we will be using the equation number 2. Tangent 42 degrees is equal to y plus height over x. So substitute tan 42 degrees is equal to 43.69 plus h over 64.78. Then let's cross multiply. So we have to multiply the 64.78 and the tangent 42 degrees is equal to 46.69 plus h. So multiply and we will get 58.33 is equal to 43.69 decimal plus h. Then we have to transpose the 43.69 to the left side, so we will be having 58.33 minus 43.69 is equal to h. So our height, if we subtract this, the height of the tower is equal to 14.64 feet. The next problem, along one bank of the river with parallel banks, a surveyor lays off a baseline AB 600 feet long. From each end of the line, an object C on the opposite bank is sighted. The angles between the lines of sight made with the baseline are 62 degrees 5.3 minutes and 81 degrees 34.7 minutes respectively. Find the width of the river. So these lines, these color brown lines, is the river. Then your baseline AB, your line AB is laying off on the baseline. From each end of the line, an object C on the opposite bank is sighted. So the opposite bank of the river is here. So the object C is sighted. The angles which the lines of sight. So the lines of sight is here. So from the lines of sight of AC is 62 degrees 5.3 minutes. Then the line of sight of CB is creates an angle of 81 degrees 34.7 minutes. So let y be is equal to, or let y be the width of the river. So we have to find this width of the river. So first is let's convert the the angle into decimal. So all we need to do is 62 degrees. We have to add the to 5.3 over 60. It is over 60 because in 1 minute we have 60 seconds, or in 1 minute we have 60 seconds. So let's divide and add. We will get the approximately 62.09 degrees. And if we convert 81 degrees 34.7 minutes into decimal, we have to add into 34.7 over 60, and we will get the approximately 81.58 degrees. Since we already have our angles, we will create our equation, which is tangent 62.09 degrees. So this one is equal to y. So tangent is the opposite over adjacent. So opposite, which is y over adjacent, which is 60 feet, 60 feet minus x, because 60 feet is only this one. Then we have equation number 2, tangent 81.58 degrees is equal to, so this is your tangent, this is your angle, another angle, the opposite is y and the adjacent is x. So we have to find, or we have to solve for our initial value of y, so we will be using our equation number 2 since it is easier to use the equation number 2. So we have tangent 81.58 degrees is equals to y over x. Then let's cross multiply. We will get y is equals to tangent 81.58 degrees times x. So let's substitute the y into the equation number 1. So we have tangent 62.09 degrees is equal to tangent 81.58 degrees times x. over 600 minus x. Then let's cross multiply and we will get 600 minus x quantity or times tangent 62.09 degrees is equals to tangent 81.58 degrees times x. So multiply, we will multiply the 600 into tangent 62.09 degrees. We will get 1132.72. And let's multiply the negative x into tangent 62.09 degrees and we will get negative negative 1.89x. We will multiply the tangent 81.58 degrees and x we will get 6.76x. Then let's transpose the x into the right side. So we have 1132.72 is equals to 6.76x plus 1.89x. So we have to add and we will get 8.65x. Then we will divide both sides into 8.65x. So we have to cancel or to cross out. So we have x is equals to 130.96 feet. So we already have our x. So let's substitute the x into equation number 2 to get the final answer or to get the width of the river. So tangent 81.58 degrees is equals to y over x. So we have tangent 81.58 degrees is equals to y over 130.96 feet. And let's cross multiply. So we have y is equals to tangent 81.58 degrees times 130.96 and we will get 884.72 feet. So the width of the river is 884.72 feet. So we have the problem number 5. Two boundary lines of a piece of property intersect at an angle of 85 degrees. It is desired to cut off a triangular portion of the property which will be 1 acre, 43,560 square feet in area by means of a straight fence. If the fence begins at the point on one boundary 250 feet from the corner of the property and runs in a straight line to the other boundary, what angles does it make with the boundary lines and how long is it? So we will be writing down our given. So the two boundary lines intersect. So this is the boundary lines. They intersect an angle of 85 degrees, which is our A, angle A. It is desired to cut off a direction. So we have our area, 43,560 feet squared. So this is our fence, which is 250 feet. I mean, our one boundary, which is 250 feet, and this is our fence. So our area is 1/2 b 1/2 times base times height. So to solve for the height or to solve how long is the fence, we have to substitute all our given into this formula. So our area is 43,560 is equal to 1/2 and our base is 250 times height. So we will get, if we multiply 1/2 into 250, we will get 125 and multiplied into h, we will get 125h. So we will have to divide both sides into 125, and let's cancel. So the length of our fence is 348.48 feet. So to find the angle that it makes, if it runs in a straight line to the other boundary, we will first get the theta and the legs of the boundaries. So we have sine, we will be using sine. We have opposite over over hypotenuse. So we have the h, or the height, the opposite of 85 degrees, and the letter b, which is one of the legs of the triangle, which is the boundary line. So we will just have to substitute. So we have sine 85 degrees is equals to 348.48 over b. So we will be having b is equals to 348.48 over sine 85 degrees. So if we divide them, we will get 349.81 feet. So our B here, or one of the boundary lines, has the length of 349.81 feet. Next, if we apply the rule in getting the other leg of a triangle, if it is not a right triangle, we will be using the cosine law, which is a squared is equal to b squared plus c squared is equal minus 2 times b times c cosine and your angle A. So we have a squared times 349.81 squared plus 250 squared minus 2 times 349.81 times 250 times cosine 85 degrees. So the square of our B is 122,367.04, and the square of our C is 62,500. Minus, if you subtract all of them, we will get 15. If we will multiply rather all of them, we will get 15,243.98. Then we have to add and subtract, and we will get 169,623.02. So let's divide both, or let's get the reciprocal of the both sides. So we have the reciprocal of a squared is a, and the reciprocal of 169,623.02 is 411.35. So this is the length of a so this is uh, the length of our other boundaries. So the height is the fence, which is 348.48. So next is the sine law. We will get the theta here. So we have sine A is equals to divided by A is equal to sine B over B. So sine 85 degrees over 411.85 is equal to sine theta, since our B, or the angle of our B, is not given, over 349.81. So we have to cross multiply. We have to multiply the denominator of the right side into the left side. So we will get, if we multiply them, we will get 0.85. So our theta is equals to sine negative 1 times 0.85. If we calculate them, we will get 58.21 degrees. So we already have our B, the length of our boundaries, and the length of our fence. So the angle of our B and the angle of our A. So the remaining is what angle does it make? So we will just have to subtract. So C is equals to 180 degrees. Let's subtract them into 85 degrees. And our theta, which is 58.21 degrees. So our C is 36.79 degrees. So the fence is 348.48 feet long, and it makes an angle of 36.79 degrees. So next, our last problem, we have the sides of a triangular glass plot are 47.5, 64.5, and 85 feet respectively. Um, find the minimum radius of action of an automatic lawn sprinkler which will water all parts of the lot simultaneously. So we have a circle here, and a triangle or scalene triangle is inscribed inside of the circle, or inscribed in the circle. So we have three legs with different measurements. So all we need to do is to add, is to find the um half of the sum of the sides. So our formula from that is a plus b plus c over 2. So we have the side is equals to 47.5 plus 64.5 plus 85 divided by 2. So if we add them, all the sides, we have 197 over 2, and we will get the 98.5 feet. And we will get the area. So we have the square root of side times side minus A times side minus B times side minus C, and square root of 98.5 times 98.5 minus 47.5 times 98.5 minus 64.5 times 98.5 minus 85. So if we subtract all the numbers inside of the parentheses, we will get the square root of 98.5 times 51 times 34 times 13.5. If we multiply all of them, we will get 2,305, 2 million rather, 305,786.5. If we get the square root of this, we will get 1,518.48 feet square. To get the radius, we will have to divide the area and the side. So we have r is equals to 1,518.48 feet squared over 98.5 feet. So we have the radius, and it is 15.42 feet. So the minimum radius of an automatic lawn sprinkler is 15.42 feet. And that would be all. Thank you.